Hello everybody, it is Caleb and I am back for another update for June 2025 of my fixture pack. This one was a bit eventful, not a lot of new fixtures, just kind of system upgrades. And so I do want to thank my Patreon sponsors for supporting me in building this beautiful showroom. Also, my Patreon subscriber list has grown long enough that OBS no longer supports that long of scrolling text. So I have to do it this way now, but it is kind of a cute little showroom. I expanded the showroom that I had previously. So I do want to thank Eterno for staying subscribed. Thank you. Secret Meeting. By the way, everybody's names is in here. Secret Meeting, thank you. Stephen Thompson, thank you for staying subscribed. Maxime Roylau Villeneuve. I'll eventually get the hang of saying your name, by the way. Aaron Sanchez, Endeavor, good talking to you about the JDC1. Tom Hill, thank you. AtsyTK, I know you're excited for this update. Here it is. I'm at Kais, thank you. I have to fix your shutter right there. Jesse Magyana, thank you. Fatih Turkman, thank you. Hope everything's working out for you. 248, thank you. Stephen Thompson, thank you. AtsyTK, thank you. Your name got put in two spots, Atsy. Alright, well, that's just how it's going to be, I guess. AtsyTK, thank you. Dini Agimba, thank you. And Adam Jackson, my most recent subscriber, thank you. And then a big thank you to Cameron Kurtz for taking the sponsorship tier. He has been using this package a lot with his church. And he's a pretty cool dude. So thank you. I've had a good time chatting with you. I also want to take a second shout out to everybody that was subscribed up to the point of me creating the Python executables. These ones. I still use them. I am sometimes a little bit impressed by them. But thank you, Kendrick Feller, Eterno, Secret Meeting, Ton Huang, Sean Dog, Stephen Thompson, Oliver Elmers, Maxime Roylau Villeneuve, Igor Nikachenko, Endeavor, Matt Ford, Tom Hill, AtsyTK, Leo Palasola, Jesse Manganya, MK Ultra, I'm at Kais, and Aaron Sanchez. You guys, from the beginning of my Patreon, your membership helped fund and provide encouragement for this endeavor. So I am going to keep going. I am going to expand into other things like I'll show you on Truss. I actually saw it's called Atlabase, and they might be able to provide fixture models and a bunch of data for all of the fixtures. So soon I'll be getting fixture models in. So thank you. Let's get into the details of this update. The biggest change this update was to fixtures with 2 rotating gobo wheels. And just know that I faced some limitations with this, and so I applied a pretty good band-aid. But know that Unreal's DMX plugin system currently only allows for 1 rotating gobo or 1 static gobo. And so I performed this workaround, but if you use 2 gobos, both rotating at different speeds, you'll start to notice this break down a little bit. But if you use 1 gobo at a time, you'll be fine. So let me go into my console, and I'll go into my gobos and open them all up. And what you were able to see right there where the gobo was spinning and then I took one out and it stopped, that's where things start to break down in this illusion. The premise that I was going by is what Cameron Kurtz said, where probably 95% of the time, most people are not using 2 gobos in their fixtures at a time. So right now, I put a gobo wheel 1 in. Gobo wheel 1 is a spinning gobo, so I'm able to spin it. The blueprint now tracks which gobo wheel spins and which gobo wheel doesn't. And so if you're building a fixture on your own, what you're going to be looking for on the triple or double gobo wheel component is this new variable I put in called which gobo wheel spins. Index 0 relates to gobo wheel 1, index 1 relates to gobo wheel 2, index 2 relates to gobo wheel 3. So if you're building a fixture, you have to check the boxes that pertain to which gobo wheels actually rotate. If a gobo is in, like if it's not on open and it's on one of the spinning gobos, then it will spin. So I can change the rotation speed. I can change the rotation speed of this gobo because it's in gobo wheel 1. As soon as I take this out, it does actually stop rotating, which should actually free up some frame rate, because as soon as you pop it back in, it'll start rotating immediately. You can't even tell that it's not rotating. Now, if I pop in gobo wheel 2, my gobo wheel 1 value is still telling it to rotate. I haven't changed that. If I pop in gobo wheel 2, which is static and does not spin, you're going to see non-spinning. That's because I updated the double gobo wheel and triple gobo wheel component to track that gobo wheel 1 and 3 are open, and those are the spinning gobos. Because they're open, there's going to be no spinning. It doesn't track, in this case, gobo wheel 2, because gobo wheel 2 does not spin. Now if I pop in gobo wheel 3, it's not spinning right now because I don't have the gobo 3 rotation value up. As soon as I bring the gobo 3 rotation value up, it will spin. Now where this illusion starts to break down is when we start layering the gobos together. So what I'm going to do is layer in gobo 2 with gobo 3. Gobo wheel 2 does not spin. When I do this, it keeps the same rotation speed. I probably could half it based on what I've done with the other gobos. Because what I've done with the other gobo wheels is if you have 2 gobo wheels that are spinning and they're spinning at different speeds, it will average those 2 speeds together. So I'm going to pop a gobo into gobo wheel 1. And right now I'm changing gobo wheel 1's speed. So let me just set gobo wheel 1 to stop, and you can see that it's still spinning. That's because gobo wheel 3 is executing the spinning. As soon as I pop gobo wheel 1 to be open, you're going to see the speed increase. This is the best I can do, the best band-aid I can do for now. And I'm considering that most people are only using one gobo at a time. Very rarely do people actually, from what I've seen, actually layer gobos together. I like to because I think it looks good. And in the future, I would like to fix this by actually rotating the texture. The problem is I have to rotate the entire 4096 by 256 gobo disc, and that causes a whole bucket of problems. It's really hard to get that to rotate. So maybe another day I will be able to get that to work. But this update is unfortunately not that time. While we're on the topic of gobos, I do want to address one bug that is recurring, and that is sometimes when you start up your project, what you're going to see is very fuzzy gobos. I might be able to see it with the Mac Viper, because that one's been notorious for it. Oh no, the Mac Viper's fine for now. But what happens is you get fuzzy gobos. They're not in detail. It almost looks like they're open or frosted. The way to fix that is to open the disks, and the shortcut to that is to simply click on the fixture, browse to asset, and open your disks folder. That will, for the remainder of the project running, correct that issue. Once it loads in these textures, you're all good. On the topic of spots, I have sort of unified a lot of the multiple modes for the spot fixtures. And while we're talking about bugs, actually, the Mac Viper AirFX has this bug that I'll show you, where, and it tends to do this more when I just start it up, but sometimes to get it to rotate, you have to go all the way up to the highest value and then back it down, and it won't actually start rotating up until you start to back it down from the highest value. I don't know why. I've gone over this a couple times. I should try rebuilding it. So let me know if this raises a problem for you, and I'll jump to rebuilding it. I'm gonna try to get that on the next update. Another update is to the JDC1 fixture. I borrowed a JDC1 from my friends over at Lit Lighting, and I realized that I had set the masters wrong. I set them to what I thought they would be, and I would still like to think the fixture works this way, but it doesn't. When you load up the JDC1 in a GrandMA, you're going to have 3 dimmer wheels when it's in SPIX mode. The first 2 dimmer wheels I don't think do anything. I have yet to find a purpose for them, despite them being called in the manual beam master for the strobes and plate master for the RGB, and then dimmer 3 being the master intensity. I only found functionality out of the master. I don't know why. I do think I'm doing something wrong, but I spent a good 4 or 5 hours just playing console to fixture, trying to get the actual JDC to respond to these 2 other dimmer wheels. I reset to factory defaults. I don't know what's going on here, but because of that, I edited the JDC1 to reflect this. So now there's only master intensity. In fact, I'm going to delete these other ones because they don't do anything. I would like to think they do something. And please, if you do know what they actually do, correct me, because I don't know what they do. So now the strobes respond to the master intensity. The color responds to the master intensity. I also added RGB color correction, which is a variable that I'll expose right now. The color correction is 0.6.61, so I found that the color plate is very blue, and so I made that. But if you do want the JDC1 to be full color, go ahead and just come in here and set this to 1 and 1. But until then, I'm going to go with the actual accurate representation of it, which is 0.6.6. Now, unfortunately, that means the reds and greens will be a little bit dimmed. So, like I said, if you want to change that, feel free to. That's the beauty of doing this in Unreal Engine, is you can change things, and you can build your own fixtures. The other thing that comes with this is some people were talking about the brightness of the JDC1 fixture. I agree. In comparison to using the real fixture, the Unreal Engine version was very not bright. And so now, even at very dim intensities, you can still see the color plate. And so I think with the masters that I had set, the colors coming through to the material were like 0.05 or 0.02. It was really low. The other improvement I made to the JDC1 was a bit on performance. And this actually I carried over to all other LED fixtures that are multi-instance, such as X4 bar 20, these use a different type of beam. I chose a very bad direction to start traveling. I made this to the B2 blinder, I think, I'll double check, S2 strobe, some other ones. What I did is create a much simpler beam material. So if we go in here, go to our beam mesh, and go to our thing, you'll see that we have a new material here called M Simple Beam Master. And what this does is it takes in far less, it looks like I don't need this one either. I'm making all kinds of changes on this video. It takes in far less variables, this GLSL here. And so it doesn't account for color wheels anymore. It doesn't account for gobos. It doesn't account for a lot of things that previously it was. And so the performance boost on that, if I have 10 JDC1s lined up in a row and I'm doing pixel chases through every bit of them, The improvement was on a i7 processor and a 3070 graphics card, NVIDIA RTX 3070. The improvement was about 29 to 30 frames a second, up to 45 frames a second after the modification. So not factoring in gobo wheels that weren't being used actually saved quite a bit of frames. I did make a small update to the X4 bar once I made these changes, and that was I widened these cells just a little bit. And so if this is bogging down your system, the X4 bar, what you can do is click on it and find the material. So select any one of these beams. It's now a common beam that's used in other, I will use in other multi-instance fixtures. And so if the blending of the beams is starting to get too much for your system, here's where you want to go. This top view texture coordinate. And you want to change your V tiling. So if I branch this off, go to my virtual convention, and then set V tiling to be like, say, 0.03. Let's go extreme. What you're going to see is these beams get really thin. And actually my performance did just go up. As soon as I bring this back, I'm going to back that off a little bit based on the performance I just saw. As soon as I go to 0.1, you'll see that they get a little bit wider and converge more. The problem comes from the convergence. And so I've worked with this fixture a lot. One way you can see what lights are slowing your project down, by the way, is you go to this lit here. Or I might say unlit or whatever, but you go to this ball here, which means it's a shader, and you go to optimization view modes, shader complexity. Here you can see what shaders are the most complex. So the ground, very basic shader. Every single light is bad. Let me just tell you that right off the bat. All of these lights are extremely expensive graphics-wise. And that's because of the ray tracing that they have to do to make the beam look like a beam. If not, it could look like Fortnite, and well, I have been venturing into making Fortnite concerts actually. But you don't want realistic lights to look cheap. And so most of that is caused by the beam. What happens is the more of these beams layer together, basically the more your camera ray passes through all these beams, the more expensive it'll get. So you can see while I'm looking through all 20 of these beams, it's extremely expensive. It says extremely bad. As soon as I turn to the side and start looking through only one at a time, it suddenly goes to not that bad. But then as soon as I look down the light again, it's now bad. So you can use this in whatever. Oh, the Valero doesn't look that bad. The reason it doesn't look very bad is because I'm using very narrow beams here. These I thought would look a little bit better, or be a little bit more lenient on the graphics card because of how they're done, but I guess not. And so that is beams. The new fixtures that I have though are the 6-bar 1000, and that comes in 36 channel mode, 72 channel mode, and a basic 8 channel mode. The other fixture I have is the Ayrton Hurricane, which apparently isn't turned on, but one thing at a time. And I think that is it. The other thing I built on this update that you can find under procedural tools is a procedural truss builder. I needed a break from working on lights, and if you guys know me and breaks, I don't do them very well. I usually just spend it working on something different. And so what this is a way to build truss quickly. Everything operates in the construction script, and so I have two actors. One of them is the truss length builder, straight truss builder. The other is square builder, which can build this. And the roof builder, that's going to come soon. I left it in there because, I don't know, maybe you guys will build it. These little pieces together. So how it works is you just drop in an actor, and then you just tell it, I want this truss length to be 15 feet. And it will add in the 5-footer if the length is long enough. If I say it's 14 feet, it won't add the 5-footer. If I say it's 16 feet, it'll add it, but won't add anything else. Eventually, I'm going to be adding a lot more truss to this and building this out further, but this is what we've got for now. So this will work at any length. I can say 100 feet, and it will do all that. Or I can say 105 feet, and it'll add a 5-footer to the end. And so I depth and height of it. I guess I should remove, oh, this is the roof builder. Anyway, all you have to do is drag it in and then specify your width. So let's say 30 feet and depth, let's say 15 feet. Expand this to complete the paperwork through the output log, but one thing at a time. So yeah, that's a new update. Hopefully that saves you a bit of time when you're building your truss segments. I think just this straight truss builder would save some time as it is, because you don't have to piece together everything and then group it together and space it out properly. You just enter in what you want, build all of your sticks of truss, and move them around however you need. In other news, the Leko is holding up pretty well with its shutters. I still don't have a body for it, so it's a par with shutters. But the shutters are holding up pretty well. One thing you really don't want to do though, and I've yet to get to the bottom of this, is you don't want to modify this blueprint so that you can operate it in standalone mode. So what I had that caused a lot of material instance and dynamic material instance problems is I edited the Leko, and on this dimmer here I added a plus, looped it back to the make map, and then added my own intensity value, which was a way to operate the Lekos in standalone mode and also highlight them if, say, they're all set to the same address and I just want to step through and focus them. What it did was this really obnoxious thing where if I would exit the level and then come back to the level, on the light itself, the shutters would be gone, and all the code that I gave for the shutters would be useless. In addition, if I even tried to use the shutters or turn off the manual intensity that I set, it would ignore that. And so what was happening is the light material, what's it called? Light function material. It's a dynamic material instance, and so it's transient and it changes from light to light. So this one's M light 323. If I grab this light, it's different, light 329. And so if I would try to operate these on their own, they would switch to a different light function material that wasn't actually linked to the variables. The beam would stay set, like you can see the shutter cuts on the beam, but the actual light would be off. So absolutely do not go in and edit this make map here so that you can add in your own intensity. Something happens, and I think basically what happened was the DMX system, when I set it with DMX and it calls all those functions like they're supposed to be called, it makes the light function material and dynamic material instance correct. If I try to operate it on my own, something happens and it gets out of sync. So don't do that. If you need to move stuff around, especially when focusing Leko, there's a button up here that cycles the transform gizmo coordinate system between world and local. And so what that does is if I need to slide this left to right, I'm using the world location here. If I switch this to local, suddenly that gizmo changes to be orientated to the actual fixture. And so that's useful for panning it up and down. That's useful for panning it up and down. And then if you want to rotate it and spin it, then you want to go to world. I do want to make a system where we can move this light wherever we want, and the yoke will stay upright, and the clamp will stay on the truss. But one thing at a time. I'm only human. But the Leko system has been working pretty well. If you want me to give you a quick recap of it, you just grab a light, and then you can change your top shutter. They're all variables in the detail panel. So you can change the top shutter, bottom shutter. You can change the angle on the bottom or the top or any of the other shutters. And then you can also put it in focus with a sharp edge, or take it out of focus and give it a blurry edge. It's not quite blurry. Maybe I'll work on that algorithm. But whose thing did I have to correct? Thought I had to fix somebody's shutter, but I'll fix it. So I think that is it for this update. It is performance and functionality. So thank you everybody for joining this month's update. If you like what you saw, go ahead and subscribe to the channel. If you learned something outside of the fixture pack, let me know. Join the Discord, join our conversations. We love to talk about lights and other nerdy stuff. And I do hope to continue progress on this. So thank you everybody. Look forward to talking with you. Bye. Now that we've covered everything, let's talk about the dual rotating Gobo wheel system and some of the limitations that the Epic Games plugin presented me. Currently the limitation is two things. One, the texture in the M light, if I could show you. The texture here, and also the same frosted texture that's in the beam, and the texture that goes to the light, you would think it would be spinning based on what you see if you look inside this lens. It looks like it's spinning. What's actually happening is the texture stays static, and the static mesh beam, the lens, and the light all spin, like the actual light spins, and you can see that. Well, what you're seeing now is the beam. The spotlight's rotating. And so because of that, the existing method of rotating gobos actually spins every gobo that's present. So I was able to multiply the gobos together so that one gobo can filter out another, but I can't make the texture spin just yet. I did try, and what happens is the texture compresses and expands based on its rotation, because it's like a 4096 by 256 texture. And by the way, that is also the reason for some of the blockiness on the textures, because if I do update this to be 512 by 512 pixel textures, we would be looking at a 8K by 512 texture in a lot of these fixtures, which would probably bog the system down by quite a bit. The other restriction I have with being able to do dual spinning gobo wheels, especially on a fixture with 3 gobo wheels, is being able to get 5 variables into the gobo update component. And this gets down to the C++ level, and so this is visible if you go to a fixture with 3 gobo wheels like the MK3 Spot, and you'll see what I did to work around that. But essentially, if we go to this triple gobo wheel and hit edit, what you'll see is that this parent class is a DMX fixture component color. Now that sounds pretty irrelevant to gobo wheels, because it is. And so if we go to our content browser and search under all, which includes engine content, if we search DMX fixture component, we see these 4 C++ classes. This is what I have to work with. There is DMX fixture component, which is the parent class for the other 3. I won't open it because it has to open Visual Studio, and that takes forever, and it's all just C++ anyway. But if we go to, say, tilt would probably be one. So let's open this and go to our tilt component. We can see that its parent class is a DMX fixture component single. What that single means is that under DMX channels here, it will call this value here, event set value no interp, and that receives one variable. The variable that you set and where it derives that value from is the DMX channel name. So if I were to set this to, say, red, it would receive one normalized DMX value from the tilt parameter of whatever fixture it's patched to. Where we could find the DMX fixture component double is any component that has to take in 2 parameters. And the only one I know of that does that is the regular Gobo spin component. And so we could find that on our Ayrton Diablo's Gobo spin component. You'll see it takes the DMX fixture component double. That means that in the Gobo spin component, right here it takes 2 DMX channels, DMX channel 1 and 2, one deriving from Gobo, one deriving from Gobo spin. So we got 1 variable, 2 variables, and DMX fixture component color gives us 4 variables. That is why I had to use the DMX fixture component color for the double gobo wheel component and the triple gobo wheel component. Because for the double gobo wheel component, if 2 wheels spin, I need to be able to get the first gobo wheel and its spin parameter or channel, and the second gobo wheel and that one's spin parameter, which do have to be placed in that order in order to be interpreted correctly. I ran into a problem with using 3 gobo wheels, and that is that I need to get a 5th parameter in there. With 3 gobo wheels, likely one is static, so one of these wouldn't require a spin parameter, but still that's 5 variables. Gobo wheel 1, gobo wheel 1 spin, gobo wheel 2, and gobo wheel 3, in addition to gobo wheel 3's spin parameter. So what I was doing before is just letting one gobo spin control them all. If you want gobo wheel 3 to spin, you use Gobo Wheel 1's spin parameter. But I wanted to upgrade that a little bit. So what I did with this triple Gobo Wheel component, if you go to, say, the MK3 spot, wherever its blueprint went, is not this at first. I actually tried to go to the C++ classes and then go to this DMX fixture component, and theoretically this should be entirely possible. Right click it, say create C++ class derived from DMX fixture component. What that does is presents this menu. From here I can choose class type public or private and then name my component, and it should show up here, but it doesn't. I actually have to exit the project, load back in, rebuild the project from its C++ components, and basically recompile the whole thing, and then I am able to access my new component. Where that stopped is that the new component was not under the right module name. So the module name was the project. These module names, if you can see right here, are module name DMX Fixtures. So I then had to set that my new component to the module DMX Fixtures for it to show up here. If I go to this Gobo, let's say triple Gobo wheel component, and go to class settings, I can change the parent class of whatever this is. I can change it to DMX fixture component single if I want. What I couldn't do was change it to my new component even after modifying the C++ class to accept 5 variables. So then the path that I wanted to take was to modify an existing parent class that was already in the DMX module. If I couldn't get my custom component in the DMX module, I should just be able to modify an existing component in C++, such as one of these, and make this able to take in 5 variables. I did so, and when I rebuilt the project and recompiled everything and finally went back in and used that component, lo and behold, I only saw 4 DMX channels here, or I think I tried to modify the double, and I still only ended up seeing 2 DMX channels. So it was then that I exited my computer and took a break, got some clarity, and realized that I just needed to Frankenstein that variable in however way possible. So my method of doing that, I realized that this doesn't need to be a super modular component, given that not a lot of fixtures have 3 Gobo wheels. And every fixture that I make is a little bit custom anyway. So what I did is this triple Gobo wheel component has a function called update component. All I needed to do was add a new input on this update component called Gobo Wheel 2 spin value, which is actually Gobo Wheel, the 3rd Gobo Wheel spin value. I just indexed them so that Gobo can be Gobo 1. Which raised a new problem. This update component updated with every DMX frame that I received. This event set color no interp, which contains the rest of the data, happens as soon as that component, or as soon as that attribute is altered. Because this is updating every frame, and this happens the moment it gets updated, you would think these two would come in at the same frame, but they don't. This one always updates first, then this one happens the next frame. So the workaround I did for it, and this solution can be flexible to your project, just take this as a note, is event set color no longer directly updates. This used to be linked to here. This no longer updates the actual content. It's just updated on, or it's just set and updated on every frame. It was updated on every frame before, but now it's set on every frame as well. Hopefully that doesn't bog the system down, but what was happening was on the Gobo Wheel 3 spin value, or this one, Gobo Wheel 2, it if I would change Gobo Wheel 3's spin value to stop, it would take that on the next update. And so the solution I came up with was event set color, when that's called, store all that data to a variable, and then set a new Boolean variable that's normally off to be, or that's normally false to be true. Data updated is true. Then this one, update component, which fires every frame, is always doing a check to see if data has been updated. If it has been updated, then it will perform all of this set functionality. And so that's what happens. This is streaming every frame, and most of the time data is not updated. But when data is updated, then I send a little event pin up here, trigger all of this, so I set my spin values, and then once that's all done, then I go about setting everything. Where it gets its data from here is this variable that I set up here. And so in the same way that this event pin used to be linked to here, whoops, this Gobo wheel data, or the new color, was originally linked to here. So that was the workaround. If anybody needs to reverse engineer or doctor, be a surgeon, that is how that is done.